Welcome to Business 275, Applied Business Analysis. I am Professor Dean, and I will be guiding you through this semester of Applied Business Analysis. So let's talk quickly about what this course is about. This course is basically a second semester statistics course, but more with a business flair to it. So you should have passed successfully your first semester of statistics, Math 210, and then this is the second semester where we get into some more interesting concepts and tools to help us solve and answer questions. So, some of the stuff that we review, the first couple chapters, chapters 7 through 9, or 7 through 8, at least 7, you should have seen before. If not, then you might want to go back and look at some of that stuff from your Math 210 course or Math 120 if you took that. So, what do we mean by statistics? So there are really two things that you need to distinguish between statistics versus probability. Are they the same thing? I would hope that you would know the answer to that question. If you do not, then you really need to take a step back and figure out where you are with this material. Statistics is different than probability. Probability is trying to form some idea of what things look like before anything has occurred. So I'm trying to understand what might happen in the future. Statistics relies completely on data. So we have to go out and collect data, and then we run it through some software or through some formulas or a calculator, your head, something, right, in order to come up with these statistics. So a statistic is usually just a number. It could be a range or something, but all statistics is it relies on data. Probability is before being seen. Statistics is after the event or the phenomenon has occurred, and then we try to infer something about it. A lot of times in statistics, we are taking a sample of an entire population because sampling the entire population is too time-consuming or costly or impossible. So again, statistics uses data. Probability, we might revise our probability thoughts or probability distribution thoughts, but that is when we don't have a whole lot of data. So let's see. The next thing we need to talk about, alright, so when we talk about probability distributions, alright, this probability distribution I've just drawn should look somewhat familiar. Yes, my drawing's not perfect, but that's okay. This should look something like a normal distribution. A normal distribution has two parameters it's described by. Its mean, mu, and its standard deviation, sigma. The mean represents the central tendency. The sigma represents the dispersion, how spread out the normal distribution is. So a normal distribution is actually a family of distributions where we can have different means and different standard deviations. It is a symmetrical distribution, meaning that if I flip it right here on the middle, then this half will fit perfectly on this half. So my drawing may not be 100% correct, but it's close enough. So for this would be a probability distribution. What we would then do is take a sample, and in order to estimate, so if we want to estimate the mean, mu, we usually do that with the sample mean, x bar. X bar is usually the arithmetic mean, where we take a bunch of different little samples, x sub I, or index by I, and we divide by the sample size, little n. And then we can also estimate sigma with the sample standard deviation, which we use as little s. Right. Other forms of so if we want to talk about central tendency, tendency, did I spell that right? We have the mean. We can also talk about the median. That's usually used when we talk about dollars. And the mode. The mode is the thing that occurs most frequently from our sample. The median is if I line everything up from small to large, it's the one exactly in the middle. If I have an even number for the sample size, then I take the middle two and usually average it. And the mean is the arithmetic mean that we talked about before. Then for dispersion, there are multiple things we can use here. We usually talk about either the standard deviation or the variance. The variance is simply the standard deviation squared, so the sample standard deviation is S, the variance is S squared, that's the sample variance, right? So those are samples. We could also talk about something much simpler, range, which is the high minus the low. So that just involves a simple subtraction. These guys here, the formulas are a little more involved. You can see those on the formula sheets on Blackboard. So that gives us a quick introduction to some of the stuff that you should already know about. And then the other thing that we need to talk about, what this course is really about. So again, it is a second semester statistics course. The big thing to remember is a lot of times we get bogged down into the details of the formula or the computer software, whatever it is we're using to come up with a number, right, which we think is the answer. You need to take a step back if you start doing that. What you really need to know is that statistics is used to, for our purposes, help make inferences. So we're doing inferential statistics. Help make inferences about a population using a sample. And in chapter 7 we'll talk about random sample, simple random sampling, different types of sampling techniques. So again, we only sample because we sample primarily because we don't want to query the entire population. It could be too timely or too cost consuming. And then the other thing we need to remember, so we're doing inferential statistics. The other thing is we're going to use statistics to help answer questions, right? So help answer the different questions. So you should every now and then take a step back and say, what is it I'm trying to answer? What is the problem I'm trying to solve? Okay, now since I remember what that is, what technique or what type of statistic can I use to help me solve that? So if I'm trying to determine if there is a difference between GPAs for men versus women in my Business 275 course, then I need to use a very special type of test statistic in order to test that claim. Right, so I could say, yes, women are smarter than men, so I want to test that claim. And it could just be they're smarter in my class, or it could be that they're not. The result could be either way. So again, take a step back, remember what we're trying to solve. So that gives us a brief introduction of what we're doing in 275, trying to answer questions and trying to do inferential statistics and build upon what we learned in Math 210.